Hi, this is Mary Montgomery for Homework 3, Part 1, Question 1, Separate the Camera Matrices. So first we're in Simple Color 3D, where we had to separate the constant buffer into two different buffers, one holding the camera data of the view and projection matrices, the other holding specific instance data of the world matrix and the object's color instance. So to make those changes work, we had to update dx_app.h, where we created the pointers to the buffers and the structs for the buffers that match what's in the HLSL file. And then in the dx_app.cpp file, we had to, again, create those buffers, our two separate buffers, connect those buffers to the render pipeline using the correct register numbers. Then in draw scene, you can see we only had to update the camera info once up here, the view and projection matrices, and then we could render two separate objects where we just update the world and color, which is all we need to update for each individual object to render separately. Looking at Part 1, Question 2, Create Unit Pyramid. First, we uncommented the unit pyramid case, so we could call this Create Unit Pyramid function as defined in modeltools.h and implemented in modeltools.cpp, where we create a four-sided pyramid centered on the origin with the height, width, and depth equal to 1. Our pyramid has 5 verts, the bottom square and the top point, 6 triangles, 2 for the bottom square, 4 to make up the sides. Here we're defining the vertices as well as the triangle faces. And then lastly, I'll run it. We have to declare the model in the dx_app.cpp. We are using the unit pyramid, as we can see here. Looking at Part 1, Question 3, 3 pre-made models using color selected 3D shader. First, we need to match our constant buffers declared in the shader to those declared in our dx_app.h. And then updating our dx_app.cpp file, we need to make sure we're using the correct shader file for our vertex shader, as well as for our pixel shader. Next, we create our models. We create our unit box model and our unit pyramid models. We need to create our buffers, one for the view projection buffer, one for the world color buffer. Then we need to initialize our world matrices so that all our rendered objects are displayed and they're not overlapping. And finally, in draw scene, I'll run. We only send the camera view and projection matrices once in one of our constant buffers. And then we render our individual objects. So we update our world and color constant buffer. This is for our first unit cube. We set our unit cube model to the context, which binds the vertex buffer, index buffer, and primitive topology to the input assembler stage to make sure we're rendering out the correct model, or cube, rendered up here. We didn't need to create a new cube model, so we have our repeated cube, so we only need to update our world matrix and color, then just render the cube again, which is our fire brick red cube back there. And then we render out our unit pyramid. We update our world and color. Then we update our sub-resource, our light green pyramid back there. We need to set the pyramid context because we need to rebind our vertex and index buffers and primitive topology to make sure we're using the pyramid vertex and index buffers. And then we can render our pyramid after we do that, which is why we see our pyramid in the back there. And finally, we just need to clean up our resources. Looking at Part 1, Question 4, 4 pre-made models using two separate shaders. First, we're looking at our dx_app.h file to see what we need to create our two shaders. So first, we have our vertex shader, pixel shader, vertex layout. But with our second shader, we need a second vertex shader, pixel shader, and input layout. We need our world matrices for our rendered objects. We have our models, cube, and pyramid. Then we need our context buffer. We need to match the context buffer to the formats in the HLSL shader files. So first we have our Simple Color 3D shader context buffer, which contains a world view and projection matrices. Then we have our color selected 3D context buffers, which has two. There's the view projection buffer and the world color buffer. Looking at dx_app.cpp, we need to create two vertex shaders, one with the color selected 3D shader file, the other with the Simple Color 3D shader file. We need two input layouts for both of those vertex shaders created here. We need to create two pixel shaders for each shader file, so one with the color selected 3D file, the other with the Simple Color 3D file. We construct our models. Then we need to create constant buffers for all of the constant buffers in all of the shader files. So first we have the two from the color selected 3D shader file, which is our view projection buffer and our world color buffer. Then our one constant buffer from the Simple Color 3D shader file, which is our world view projection matrix buffer. Next, we initialize our world matrices so we can render the objects in different positions. And finally, our draw scene. So we're initially using the color selected 3D shader, I'll play. So we update our VS, PS, input layout, and constant buffers accordingly to the color selected 3D shader. So color selected 3D shader has our two constant buffers. We set them before rendering. We update the buffer with the camera data here. Then we update the buffer with the instance data here with the world and color. So first we're rendering this cube model. We need to set it to context to make sure we're rendering a cube. So we're binding the vertex and index buffers and primitive topology to the input assembler stage with the set to context call to make sure we're rendering a cube. When we render, we get this hot pink cube. For object 2, we're creating a unit pyramid, still using the color selected 3D shader. So we need to update just the instance data of the world matrix and the color here, our light green pyramid. We need to set the context again since we're rendering the pyramid. So we need to bind the vertex and index buffer of the pyramid and the primitive topology of the pyramid to the input assembler stage. Then we can render the pyramid, our light green pyramid here. Next, we're switching to the Simple Color 3D shader. So we need to update our VSPS input layouts and constant buffer. Now we only have that world view projection matrix constant buffer. So all data needs to be updated every instance, which is updated here. So we are creating a pyramid. We don't need to set the context since we have already set it to the pyramid and we're using the correct index, vertex buffers, etc. Next, we need to render another cube. So we need to update the constant buffer again with the world view and projection matrices. And then we need to set the context as well since we're switching back to rendering a cube. So we need to bind the correct vertex, index buffers, primitive topology to the input assembler stage. We can render that final cube. So since Simple Color 3D shader does not specify a color, we're just using the model's default color, which is declared in this modeltools.cpp file. So we can see the unit box default color is yellow, which is why this cube is yellow. Pyramid's default color is white, which is why this pyramid is white. Then finally, we just clean up our resources. Looking at further work question 1, we can render repeated models on the screen by using one pre-made model instance. So the advantage to this, with one model, we can re-render as many times as we need. So say the model was a tree that was going to be rendered 1,000 times in a forest scene. The model would store the vertex and index buffers, which would save memory of not having to recreate these 1,000 vertex buffers and 1,000 index buffers. We are also making it easier to render, since we only need to adjust the world matrix for each of these models in order to render them out exactly where and how we want them. Plus, it's easier to keep track of this one pointer and move hundreds of lines of code to a separate file, so this massively increases the readability of our files. Looking at further work question 2, this is my attempt at a shader header file. So I'm thinking about it like the model class. I would need everything directly a part of the shader within this file. So that would be the context buffers, which I'll cover below, the GPU connections, we have the device, and we have the vertex shader blob and the pixel shader blob. Then we have this private load data to GPU function, which would do all of the initialization, make buffers, bind the shaders, etc. Our public functions, we would at least need the big four, the constructor, copy constructor, assignment operator, and destructor of the shader class. And we would have an enum for our different shaders. Within these individual shaders would be the constant buffers, which is what I was saying up here. So we definitely need the constant buffers in there, but just I don't think they would be a part of the shader class in general. They would be part of each of the individual shaders classes. And then finally, we have functions involving the shader that I believe could be moved into the shader class, which includes the compile shader from file, create vertex shader, create input layout, IA set input layout, and create pixel shader function calls. For part 1, question 5, create unit sphere, I've not yet gotten this to work. I feel like I can visualize it so clearly in my head, but whenever I try to code it, it just sticks in my head. It doesn't want to come out into code. But I'm trying to create the initial curve from 0, 1 to 0, -1 and plot those points, then just rotate the normal vector around the y-axis some amount and draw the curve over and over to make all the vertices. But I haven't yet gotten through it. I tried initially to do it with the sine and cosine, but that seemed inefficient and kind of stupid. And this rotation seems a lot better, but I just haven't gotten it to work yet, so I'll continue to work on it.